This question is from GATE 2022 Mechanical Engineering paper, set 2, question number 37. A rigid homogeneous uniform block of mass 1 kg, height h equal to 0.4 meter and width b equal to 0.3 meter is pinned at one corner and placed upright in a uniform gravitational field g is equal to 9.81 meter per second square, supported by a roller in the configuration as shown in the figure. A short duration impulsive force F producing an impulse IF is applied at a height of d equal to 0.3 meter from the bottom as shown. Assume all joints to be frictionless. The minimum value of IF required to topple the block is dash. Let's find this out. So we'll start by writing the given things first. Width of the block B is given to be 0.3 meter. Height of the block H is 0.4 meter. Acceleration due to gravity G is given 9.81 meter per second square. And height at which force F is applied, D, is given to be 0.3 meter. Also mass of the block is given 1 kg. We need to find out the impulse, IF. So using the impulse momentum theorem, we can write angular impulse IF into D will be equal to change in the angular momentum delta L. Delta L can be written as final angular momentum minus initial angular momentum. Here we know that initial angular momentum of this block will be 0 because initial angular momentum we are considering at the stage where F is not applied. So before applying F, its momentum will be 0 because it is not undergoing rotational motion. Whereas LF will be a non-zero value because after applying IF, the block will start rotating about this point. Let this point be A, this point be B, and center of mass of this block be C in this cross section, of course. So here we can say when impulse is applied, the block starts rotating about point B and therefore LF will be non-zero. Also we can calculate this value LF. So impulse IF into D is nothing but 0.3 meter, will be equal to LF will be written as mass moment of inertia of the block about point B because rotation is happening about point B. We'll take the moment of inertia of the block also about point B into angular velocity of the block omega. So in order to find out IF, we will require IB and omega both divided by 0.3. So let this be equation 1. Once we find out IB and omega, we can substitute it here and find out IF. So let's first find out IB. For this rectangular block, moment of inertia about point B. That means we need to calculate moment of inertia about an axis that is perpendicular to the plane of the screen. So if we consider that this axis is X, this one is Y. So the other negative side will be X dash, we can say. And here negative Y side will be Y dash. Similarly, the perpendicular axis we can take as Z, Z dash. So what we need to find out here is IZ, Z dash. So IB will be equal to IZ, Z dash. We know that moment of inertia about the third axis will be equal to sum of moment of inertia about the two perpendicular axes. So Z is perpendicular to XY plane and therefore IZZ dash will be sum of IXX dash and IYY dash. IXX dash here is nothing but the moment of inertia of this block about its base. How can we calculate that? So we need to know moment of inertia of the block about its own horizontal axis that is passing through its center of mass. So let this be small x, x dash. We need to know this value and then we can use the parallel axis theorem to find out the moment of inertia about the base. So Ix x dash will be equal to I small x x dash plus mass into distance between small xx dash and capital XX dash is nothing but half of this height h. So it is h by 2 square. Now this will be a standard formula which you need to know, which is given by mass into height square upon 12. This is a standard formula you must remember. Plus mh square by 4. So by adding this we get 4 by 12 mh square and 4 by 12 is 1 by 3. So this is mh square by 3. Similarly, we can find out first I small y, y dash, and then by using parallel axis theorem we can find out the moment of inertia of the block about this right edge, which is capital Y, y dash. So that will be written as I y dash will be equal to I small y dash plus m into b by 2 square. So instead of h, we have b here. And therefore, we will get this as mb square by 3. So if we substitute it here, IB will be equal to m by 3 we take common, and in the bracket we get h square plus b. Let's substitute the values and find out IB. So IB will be equal to mass is 1 kg upon 3 into h is 0.4 square of it plus b is 0.3 square of it. So we get this as 0.0833. The unit is kg meter square, because this is moment of inertia. So we have IB. Now we'll go for finding out omega. So let's do it. Second, for omega. For finding out omega, we'll use law of conservation of energy. So by energy conservation, we know initial energy of the block will be equal to its final energy. Initial energy and final energies both can be written as sum of kinetic plus potential energies. So initial kinetic energy plus initial potential energy will be equal to final kinetic energy plus final potential energy. Now you have to carefully pay attention here. So initially the block is resting on this support, and as soon as IF is being applied to the block, it will be set in motion, and kinetic energy of the block will be given by rotational kinetic energy, which is half into IB into omega square, because the rotation takes place about point B and we have assumed that its angular velocity is omega. While potential energy of the block will be 0, because we consider that this is the datum, and here when we are taking energies, we are actually taking both the energies values for center of mass, that is of point C. So when center of mass is at datum, its potential energy will be 0, while after impulse is being applied, the block is going to rotate. And now this block will be on the verge of toppling only when the weight creates a clockwise moment on this, because at this stable position, the weight of the block that is acting downwards is creating an anti-clockwise motion, and therefore it is resisting this impulse. But when the weight starts creating a clockwise moment, it is going to topple the block. Impulse here is just applied for a fraction of time. So the impulse should be high enough that it brings the block into such a position that further rotation will make the weight to create a clockwise moment. That is, the block should be in this particular position. That is, weight is just acting on a line that passes through B. Of course, the line is perpendicular. When the impulse is high enough to bring the block at this stage, then further, even after removal of this force, the block will topple on its weight itself, because its weight will then create a clockwise moment on the block. Actually, this surface is inclined, so we should show an inclined surface here. And therefore, we see that center of mass has now moved to a new position C dash. Earlier it was somewhere here C. So the height by which the center of mass has moved, that much potential energy will be gained by the block. And let this distance be S. So kinetic energy finally of the block will be 0 because impulse is being removed. So this is 0 plus potential energy will be written as weight of the block into this distance S, which is m into g into S. Now we can find out S because we know this distance. This inclined distance we can find out by considering this right angle triangle here. Let that distance be R. We can find out R. Also, we can find out the initial height of center of mass from the base of the block, which is nothing but h by 2. So S will be this R minus h by 2. R can be calculated as under root of h by 2 square plus b by 2 square. Don't forget to take the half of h and b minus h by 2. Substituting the values here, we have this will be equal to under root of h by 2 is 0.2, so 0.2 square plus b by 2 is 0.15, so square of it, minus h by 2 is again 0.2. S becomes 0.25 minus 0.2, which is 0.0 meters. So here in this equation we know IB, we know S, G and M. All of the values. We need to find omega, so that we can do here. Let's rearrange this equation. So omega square will be now equal to 2 into mass is 1 kg into g is 9.81 meter per second square into s is 0.05 divided by IB value we have calculated 0.0833. So now to find out omega, we'll take square root on both sides and calculate this value as well. This gives us omega is equal to 3.431 radians per second. We have omega, we have IB. Let's go back and calculate IF here. So IF as we evaluated over here is IB into omega by 0.3. So IF will be 0.0833 into omega is 3.431 divided by 0.3. This gives us the answer as 0.952 Newton second because it is impulse, force into time, that is Newton second. Let's go back and mark this option. So 0.953, only the third decimal place is varying, so it's not a problem. The option that matches is option A. Minimum value of impulse required to topple the block is 0.953 Newton second. To learn more about impulse and momentum, you can refer to the NPTEL video, Module 11, Lecture 29, Impulse and Momentum. It is from the course Engineering Mechanics. The course is taught by Professor U.S. Dikshit. He is from Department of Mechanical Engineering of IIT Guwahati. I hope this solution helps you clear your doubt. Thank you.